Okay, Algebra 2 fans, our topic for today is two things. We're going to talk about a composition of functions, and then we're going to talk about inverse functions. So before I start here, let me give you your joke of the day. Why did the golfer wear two pairs of pants? And the answer is, in case he got a hole in one. So we're going to start with a review here on operations and evaluating functions. So let's say I give you two functions. F of x equals 4x plus 2 and g of x equals 2x minus 3. Now both of these, remember that a function is just a situation where you plug in a value for x and you get a value for y. And the idea is that the x values can never repeat for that. So this is the same thing as y equals. So this is y equals 4x plus 2 and this is y equals 2x minus 3. So if you want to find a y value, you plug in a number for x. Now we can do things with these functions. For example, number 1, perform each operation using functions f and g. If you want to, part A, you could add the two functions, f plus g. So the f function is 4x plus 2, and the g function is 2x minus 3. So we're going to add those, combine like terms, so you have 4x plus 2x, which is 6x, and then you have positive 2 minus 3, which is negative 1. Now you can't combine that, so you're done. Part B, let's subtract the two functions. So 4x plus 2, that's the f, minus, now I'm going to put the g function in parentheses, and the reason is, when I subtract, I'm subtracting both terms here. So 4x plus 2, I have to distribute this minus. This is like a minus 1. So minus 1 times 2x is minus 2x. Minus 1 times negative 3 becomes a positive 3. Combine like terms, so we get 4x minus 2x, so we get 2x, and then we have positive 2 plus 3, which is 5. And that's as far as you can go. We can also multiply functions. Okay, so f times g would be 4x plus 2, I'll put that in parentheses, times 2x minus 3. And to multiply this, we're going to double distribute. So we're going to distribute the 4x to the second set of parentheses. 4x times 2x is 8. When you multiply the variables, you add the exponents. So x times x is x squared. 4x times negative 3 is minus 12x. And then 2 times 2x is 4x, positive. 2 times negative 3 is minus 6. Now we combine the like terms. So you have negative 12x plus 4x. So 8x squared. This will be minus 8x minus 6. And that's as far as we can go. The x squared term is different from the x term, which is different from the constant. So that's as far as you take it. Alright, so we can add, subtract, multiply. You can also divide the functions. We're not doing that in this case, but you can divide functions as well. Number 2, evaluate each function for the following domain values. So f of 0, what that means is that x is 0. What's the y value? So if you plug in a 0 into the function, what do you get out of that? So remember that the x's are the domain and the y's are the range. So if they give you a domain value, in this case f of 0, I'm going to take the f function, which was 4x plus 2, and in place of the x, I'm going to substitute the domain value, the x value, which is 0. And then we evaluate. Okay, we work it out. So 4 times 0 is 0 plus 2, and we get positive 2. That's it. G of negative 3, so we're going to go to the g function, which was 2x minus 3. Now they're giving us, again, they're telling you that the x value is negative 3. So in place of x, we substitute. And now you work it out. 2 times negative 3 is negative 6 minus 3, which is negative 9. Now what's new today, we've done that, we've evaluated functions. What happens if you have more than one function? Or what we call a composition of functions. Composition of functions. If you make a music composition, that means you're putting together a bunch of different ideas or a bunch of different instruments and notes and things like that. So composition is kind of like putting things together. There are a couple ways to look at it. The way that I'm reading this is f of g of 2. I'm reading this f of g of 2. So we actually have two functions here. Where do you start? Well, the rule is we work from the inside out. Okay, so work inside out. So we're going to start with the g function. We're going to take the g function and we're going to put a 2 in for the x. So I'm going to do g of 2. And so the g function was 2x minus 3. The x value was 2. So that's 4 minus 3, which is 1. G of 2 equals 1. When you plug a 2 in for x, you get 1 for y. Now, what I'm going to do, since g of 2 is equal to this value 1, I'm going to rewrite this, and I'm going to write it as f of, instead of g of 2, that's equal to 1, now it's f of 1. So what that tells you, now you go to the f function, which was 4 times x plus 2, substitute the x value, which is 1, and we get 4 plus 2, which is 6. That's the answer. Okay? So if you have a composition, it just means you start with the inside function, you work that out to get your value, and then that value becomes the new domain. So 2 is the domain. We put it into the g function, and what we got out was the range, which was 1. That range becomes the new domain for the outer function f. We plug that in, and we get the overall function value, the y value, which is 6. Now, you can write it as a couple sets of parentheses. You can also use notation like this. If you have brackets, g, and it looks like a little circle, and then f, and then in parentheses you have 2. The way we read this as is g composed with f of 2. G composed with f of 2. Now that's the same thing as writing it g parentheses f of 2. So we can write it just like we did in part C. If you're more comfortable with that, without this little symbol here, left to right, we're going to work from the inside out. So we're going to start with the f function this time. So f of 2, now the f function was 4 times x plus 2. Well, I'm going to substitute a 2 in, and then we do 4 times 2 is 8, plus 2 is 10. So f of 2 is equal to 10. So now we're going to go, I'm going to rewrite this. So we have g, and instead of f of 2, that's equal to 10, so I substitute a 10 there. So now we go to the g function. The g function was 2 times x minus 3. Our new domain value is 10. So you do 2 times 10, which is 20, minus 3, and our answer is 17. Okay? So with a composition, all you're doing is evaluating twice. Or if you had 3 functions, do it 3 times. Let's say we do, so party, f composed with g of x. Let's say they don't give you a number, they just give you that variable x. All right, so let me think about it as f parentheses g of x. You may also see it as f, they may use a bracket just to keep this a little more separate from the parentheses, because you have a lot of parentheses here. So any of these all mean the same thing. Start with g of x. Now, g of x, they give to you, they tell you that that function is equal to 2x minus 3. Now again, we're not substituting a number here. We're just substituting the variables, so nothing will change. This is 2 times x minus 3. Well, I'm going to take this and I'm going to now rewrite the composition f composed with, instead of g of x, I'm going to substitute 2x minus 3. Now the f function was 4 times x plus 2. Anytime I have my variable, I put a set of parentheses. 4 times this x plus 2. Now, in this case, what am I substituting in here? It's 2x minus 3. So I put 2x minus 3 there. Now I distribute, so I get 8x minus 12 plus 2. We can combine negative 12 plus 2, and we get 8x minus 10. So that's it. That's all you can do with that. Don't get confused if you are substituting a variable, if you're being more general than substituting an actual number. It's the same thing, the same process. What if we reverse it? What if we do g composed with f of x? So this time, you would start with the f function, which is 4x plus 2. Now I'm going to take that, and that's going to go into the g function when I rewrite this. The g function was 2 times x minus 3. Now my x value, what I'm going to substitute there, is 4x plus 2. Okay, this is my new domain, so that goes into the parentheses. Distribute, we get 8x plus 4 minus 3. Combine 4 minus 3, we get 8x plus 1. And that's as far as we go. Alright, so let's take number 3 here. So we'll do two new functions. We've got f of x equals 2x squared plus 3, h of x equals x plus 4. So let's first find h of f of negative 5. So we're going to start with f of negative 5, the f function. Well, the f function is 2x squared plus 3. Now we're going to substitute negative 5. First thing you would do is you'd square. When you square negative 5, you get 25, which is 50. 2 times 25, 50 plus 3. So what we get here is 53. Now I'm going to substitute that in place of f of negative 5. So what we have is h of 53. So now we'll go to the h function, which was x plus 4. So 53 plus 4. And you get 57, and that's your answer. Everything we do here, it's step by step. Start with the inside function, work it out, and then whatever you get for that value, whether it's variables or just a number, you replace it in the original problem, and then you move to the next function, and you plug it in. So let's do one more part here, part B, f of h of x. Start from the inside out. H of x, that was equal to x plus 4. Okay, so I'm going to rewrite this expression as f of, instead of h of x, I know that that's the same as x plus 4. So now we go to the f function. Now the f function was 2x squared plus 3. Instead of putting a number in here, I'm going to put the expression x plus 4. Now to work this out, first thing I need to do is square x plus 4. So over here on the side, when I square a binomial, that's the same thing as multiplying it by itself. I'm going to double distribute, so we get x squared plus 4x, and then distribute the 4, so plus 4x again, plus 16. Combine the two like terms, you get x squared plus 8x plus 16. Okay? So let's come back over here. So we have 2 times x plus 4 squared was this, x squared plus 8x plus 16, and then plus 3. Distribute the 2. 2x squared plus 16x plus 32 plus 3. Last thing we can do is combine those, and we get 2x squared plus 16x plus 35. And that is the end of part 1 of the notes.